Okay, so here we're going to look at some confidence intervals about the mean, and we're going to assume we know the population standard deviation. It gets a little trickier when you don't. So pause on that for a little bit and go with this. Point estimates when you're doing something like saying, I think the average is, and you have a certain number. An interval estimate will be when you say, I think the number's between this and this. Like, I think the average is 78 would be a point average. You say, I think the average is between 75 and 80 would be a interval estimate. I should say a point estimate. So if we're trying to find a parameter such as mu, we don't know that it's 3, we have to have an estimate from a statistic. And a lot of times it's close, and like we want to know how close it is, but that can be hard to determine. So we'll try to put some bounds on things. That's what we do usually. So we'd like to know how confident we are of getting something in our estimate. So we're in Chapter 8 here. Point estimates is the plus the margin of error gives you an interval estimate. Sorry, it jumps this thing up when I do that. Now, when we talk about margin of error here, it's not the margin of error we were looking at before. Way back in the beginning of the text, we looked at estimating the margin of error for proportions, where it was 1 over the square root of n. That's still true. Margin of error is simply a general term. So, we're going to look at margin of error from this one. That's from page 338 in your textbook. So I would suggest you read that. We're also going to look at something, a term called biased or unbiased. A couple qualities for that you want in an unbiased estimate would be that its center, like the median or the mean, matches that of the population. You'd also like it to have as small a variation as possible. Those are the two characteristics you're going for with it. So when we're doing this, we like how confident we want to be. Do we want to be 50% sure? Do we want to be 90% sure? Do we want to be 99% sure? That's where the confidence part of confidence interval comes from. The second part will be population standard deviation, because that's really going to determine it. And how large your sample size is also does. Now this expression looks hideous, but in fact it's not as bad as it looks. X bar you already know. Sigma you already know. Square root of n you already know. So you just have to figure out what this z part in the middle is. And all it really is, it's a particular z number based on how confident you want it to be. So, suppose we want to be 95% sure. That means we're 5% unsure. So if you take that 2.5 at this tail, 2.5 at that tail, that's 5%. That's 5% over 2. So we're going to be 2.5% unsure at either end. We call that a two-tailed. And we have an interval this way. If it's one-tailed, you don't have an interval. It just goes forever in one direction. So alpha is 0.05. That's this 2.5% or 0.025 added to this 2.5 or 0.025. And that's what the alpha over 2 means. You take the 5 and divide it by 2. And when you have an alpha of 0.05, your z is always going to turn out to be 1.96 here and negative 1.96 here. In fact, this is the empirical rule, done a little more precisely. The empirical rule says 2 standard deviations for 95% under the curve. It's not actually 2 standard deviations. It's 1.96 in either direction. It's pretty close to 2, so they just rounded it for you. And if you look at the z table, I'm going to stop this so you can see his. You find the 1.96 that you need by looking at the 0.025. Remember, we're looking at the right-hand side, 0.025, so we have to take that from 1, we get 0.9750. So the z-tables only do from that point to the left, and we see that we're actually 1.96 standard deviations to the right of the mean. Basically, you would just memorize this when it's a 0.05 alpha level. You'll use 1.96 plus or minus. So he's showing it to you there, the actual numbers that you'll use. So we're going to do x bar plus 1.96 times the standard deviation over the square root of n, and the same thing but minus. So here's our example. So we know the standard deviation in this case because he made it up. Said we know it. We have a n of 25 because we had 25 test takers, and their average score for the SAT was 520. It says construct a 95% confidence interval about the mean. So he's done it here. Let me explain to you what he's got. He's saying that he's 95% sure that the mean will be 520 in this interval. Okay? I'm sorry, I should rephrase that. He's saying that from the sample, he can say that unusual for the verbal section of the SAT, 95% of the people will fall in this range. So that's from 480.8, so 481 approximately, to 559. Now if you wanted to be 99% sure, you would not use alpha of 0.05, use alpha of 0.01. Anyway, it would be 3 standard deviations approximately. So he's saying he's 95% confident that the mean SAT score is between these two. So confidence interval, point estimate, and margin of error in these terms.